Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this channel we talk about all things Gen Chem related. On this video, I'm going to be introducing you to simple gas laws, and we're going to really focus on Boyle's law. Let's get started. As we continue through this material, we're going to discuss a number of different gas laws that you're going to want to be familiar with. Now, there are three main gas laws that we'll focus on. There's Boyle's law, which we're going to cover in this video. And then there's Charles' law, which we'll cover in a later video, as well as Avogadro's law, which will come in a later video. Now, there are four basic variables or properties that we're going to associate with gases, and you'll want to be able to identify the units as you're looking at the problems. And so the units that we're going to be looking for are pressure units, volume, temperature, and the amount of substance that's present, or the moles. Now, notice for the variable, the sign that we use for moles is actually N. And the reason that is that's because we're looking for a number of moles that are present. Now, all of these properties are interrelated with one another. And what that means is if one changes, that can affect one of the other ones. And so these simple gas laws are simply describing the relationships between pairs of these different properties. Okay, so each one of these, Boyle's law, Charles' law, or Avogadro's law, are all tied to two variables out of the four. We'll learn in a later video about the ideal gas law, which is going to incorporate all four. So with Boyle's law is really looking at the relationship between pressure and volume. A great way to remember this is that you can boil potatoes and vegetables. Okay, so it's a mnemonic device. So boil, potatoes, P for pressure, and vegetables, V for volume. Now, how this law came about, so there were two scientists, Robert Boyle and Robert Hooke, who used this J tube to actually measure the volume of a sample of gas at different pressures. And so that tube was actually filled with mercury. And as they changed the volume, they were able to actually compress the gas and increase the pressure. And so you can see that the volume of gas ended up changing under the different circumstances. So when we increase the amount of mercury that's in there, changing the pressure, notice that the volume became much smaller. When the pressure was lower, less mercury, the volume was bigger. And so what they were able to find from this experiment was that there was in fact an inverse relationship between volume and pressure. So what inverse relationship means, as pressure goes up, the volume will go down, or vice versa. You'll want to remember those because oftentimes you may be posed with a question, not really a quantity question, but just a qualitative question of asking you to figure out, okay, if I change the volume like this, what would you expect to happen to the pressure? So just remember inverse. As one goes up, the other one goes down. So Boyle's law, again, is looking at the inverse relationship between pressure and volume. Now, important with all these simple gas laws, what that means is that the other two variables that are not represented in this equation are held constant, meaning they're not changed. Somehow, some way, under these whatever conditions they're exploring this in, the other conditions are remaining constant. And so when we look at the relationship graphically between pressure and volume, if we were to graph that, what we would end up seeing is this curved graph line. And that's basically showing us that as we change the pressure or the volume, the correlating part will change as well. So notice as I go down in pressure, my volume is getting higher. Lower pressure, higher volume. Okay, so it's a curved line. And if we looked at the inverse relationship between pressure, if we looked at the relationship between pressure and the inverse of volume, that's where we would see a straight line. And so if we were to graph pressure versus the inverse of the volume, you would get a straight line, okay? And so again, take home message, as pressure increases, the volume will decrease. All right, and so because of this relationship, we can develop what is called Boyle's law. So Boyle's law, what you're gonna want to remember is that the equation is P1 V1 equals P2 V2. And this should look pretty similar to you if you've looked at my other videos where I talked about the dilution formula, that M1 V1 equals M2 V2. It's the same premise where your P1 and V1 conditions, those represent your original or your starting conditions, and your P2 or V2 represent your final conditions. Okay, and so when you're reading these problems, you have to try to figure out which condition am I solving for? And you also want to make sure that when you're using this, that your units match up. If you're in atmospheres on one side of the equation, you have to be in atmospheres on the other. Or if you're in milliliters, you got to be in milliliters. So make sure that your units are matching up. And so again, here, this is just showing that graphic relationship that I was hand drawing a few seconds ago. But again, just remember, it's a curved relationship. This curve is representative of an inverse relationship between the variables. Now, if we look at Boyle's law at a molecular view, again, we're going to see the same idea. The fact that as I adjust the volume, the container that these molecules are in, it's also going to change the pressure. So if you look at the picture that's shown below, you can see where I have a certain volume, a 1 liter tank. And when you look at the pressure gauge, it's measuring at 1 atmosphere, okay? Now notice when we decrease the volume by half, right? We've reduced the volume by half. Well, now those molecules that are in there, they can bounce off the surface a lot more. The surface area has been reduced. And so as a result, the pressure that's being generated goes up. How much does it go up? By twofold. Okay, so you can see that increase. So as I halved the volume, my pressure was doubled. Okay, so let's get into a problem. It said a balloon is placed into a bell jar and the pressure is reduced from 782 torr to, I can't see the number, 2.5 atmospheres. Sorry about that. If the volume of the balloon is now 2.78 times 10 to the third milliliters, what was it originally? Okay, and so if we look at this, we are at 782 torr, and it's being reduced to, I believe I said 0.5 atmospheres. And the volume is now 2.78 times 10 to the third milliliters. So the question that's being posed to us is, how much was the volume originally? So we're looking for our V1. And so now if we think of our equation, P1 V1 equals P2 V2, we're solving for V1. So I like to rearrange my equation up front. You don't have to do this, but I prefer to. So V1 would equal P2 V2 divided by P1. Now, before we get ready to just simply plug and chug the numbers, you should have a red flag going off. What should be coming to mind is the fact that, well, wait a minute, my pressure units are not the same. So one of those has to change before we plug it into the equation. And so for me, I likely am just going to change from torr to atmosphere because, again, atmosphere is that base unit that I want to get to. So I can take my torr, 782 torr, and I want to convert it to atmospheres. And so I'm going to use the relationship that there is 760 torr for every 1 atmosphere. And so when we get that, if we take 782 divided by 760, what we end up with is 1.03 atmospheres. And so that's what we're going to plug in for P1. So P2 we know is 0.50 atmospheres. V1 is 2.78 times 10 to the third milliliters. And we're going to divide by our P1 now in atmospheres. Okay. And so when we do that, we get 0.500 times 2.78 e to the third divided by 1.03. And when we do that, we plug that in, we end up getting 1.35 times 10 to the third milliliters. And if we look, that should make sense. We notice that our pressure went down. It went from 1.03 to 0.5. So it decreased. And so I'm expecting that my volume should have an increase. So we see that originally we were at 1.35 and it almost doubled at 2.78. Okay, so keep those, do some kind of conceptual checks before you go with an answer. I hope this video helped you understand Boyle's law and how to actually do the calculations. Be sure to come back to see the other simple gas laws, your Charles law and Avogadro's law, in future videos. Be sure to like, comment, and subscribe, and let me know what other content you would like to see, and I'll see you guys in future videos. Have a great day. Talk to you guys soon. Bye-bye.